Hello there and welcome back to Eurosatory News. I am joined by Steve BLEYMAIER, who is with ANSYS. Welcome to Eurosatory.
Thank you very much.
Is this your first time here at Eurosatory?
It is.
Yes. How are you finding your experience so far?
I'm very impressed. It's one of the largest aerospace and defense shows that I've ever been to.
Wow. And you yourself, you are an Air Force veteran of how many years?
I was in for 28 years in the U.S. Air Force.
28 years, just like the 28th edition of this Eurosatory.
I guess so.
Yeah. Tell us, who is ANSYS?
So ANSYS is the world's largest physics-based engineering simulation company. We do modeling simulation from the microchip all the way up to the systems of systems and to the mission. And we're 54 years old. Over those 54 years, we've either developed the best of breed simulation technology, partnered with the best, or acquired the best. So now we cover the entire portfolio of physics-based engineering simulation.
54 years old. What would predictive technology simulation look like at the, I guess, in the inaugural stages of ANSYS?
So in 1970, the founder was working in the Department of Energy at Astronuclear Laboratories in Pittsburgh. And he developed a code to simulate how to, a nuclear reactor prior to actually building one.
Yeah.
And he wanted to pursue that further. The leadership at the time was going in a different direction, and he decided he wanted to leave the company and start ANSYS, and they allowed him to take the code with him, and that became the first simulation code for ANSYS, which was structural analysis. And over the next 30 years, ANSYS was known as the Structural Analysis Simulation Company. And around 2000, they decided to expand that and began a series of acquisitions and partnerships to grow to the $2.4 billion company they are today, where now we cover, like I said, the entire portfolio of physics, all the way up to the mission and digital mission engineering.
It's interesting because a lot of us laymen have this impression of conceptualization, experimentation being you get in with the tangible product, whatever prototype stage it's in. If it fails, it fails. If it doesn't, it doesn't. But this is much, much, much more beyond that. This is predictive. This is seeing it without, as I've said, cutting the metal, so to speak. Seeing how this will progress without having to invest heavily in prototype after physical prototype after physical prototype.
Exactly.
I imagine for you, given your history with the Air Force and your firsthand knowledge, it's also equally important to find a way to turn legacy portfolios forward in terms of turning the page, so to speak, bringing in this kind of technology and even pivoting towards the future in terms of a tranche of vehicles, of weapons, of instruments that need to be forward-facing. How does that work in terms of ANSYS and something, for example, the Department of Defense for the U.S.?
Sure, and you did describe that quite well, that the purpose of modeling and simulation...
My New York poetry.
The purpose of modeling simulation is to eliminate physical prototypes or reduce physical prototypes as much as possible. And you're able to do that during the development of new weapon systems, and using simulation as early as possible in the concept development design phase. The earlier you use it, the greater of an impact you have on the future cost of operations and sustainment, because those costs are baked in very early during those initial milestones of concept development, design, and manufacturing. Once a platform is fielded, and if you look at the weapon systems that across the world that are fielded, much of them don't have very much digital thread. So it's a challenge to back end, this digital technology into sustainability. But it is quite possible. There's an ocean of data available already on those weapon systems. That data can be harvested, through data cleansing, through artificial intelligence, through algorithms, and then that can be combined with physics-based, real-time physics-based simulation, either coming off of the weapon systems real-time or through synthetic, where they make synthetic examples of or twins of those actual systems, and by combining the physics with the predictive analytical data and artificial intelligence, you're able to achieve a predictive confidence level of 98% of when a system's going to fail.
That's a huge contrast from what I imagine was the traditional alternative to studying and going out into the field, so to speak, and experimenting with the actual hardware. I also imagine that it's much more low cost in contrast. The cost of using simulation versus using traditional methods.
Well, it is. One of the benefits of using simulation is that you reduce cost. Anytime you can reduce building physical prototypes, which are extremely expensive, you're going to reduce costs. You're also going to reduce the amount of time it takes to bring something to the field. In the case of defense, it's to the warfighter. In the case of commercial, it's to the market. But you're going to reduce that time. You're going to reduce risk, you're going to reduce costs, you're going to reduce schedule, and you're going to increase performance. The reality in the aerospace and defense world is that the systems that are being required are becoming more and more complex. But the demand for those systems is increasing. They want them faster, and the reason for that is because of the threat. Our competitors
are continuously adapting, I imagine.
Are going faster. They're getting ahead of us in certain technology areas. And so that's almost a dichotomy when you have systems that are increasing exponentially in lines of code and complexity, and the demand for them is also going up. Well, the solution for that is digital engineering, and there's this imperative for digital engineering, and ANSYS is part of those technologies that can enable digital engineering and help bring digital engineering forward.
Why is it important for ANSYS to be here today in Eurosatory 2024?
Well, you can look around, and almost every company that you see here is a customer of ANSYS. I mean, everyone today is using physics-based engineering simulation because it's the game changer. It does save time, it does reduce risk, it does save money, and you can go faster. We are the
common denominator.
We think we're the best.
Yeah.
What sets us apart is that we are open. We're an open architecture. So that means that we don't come in and displace whatever solutions a company is already using. We're able to connect to whatever they have and add value to whatever they have. We're also mission-centric, meaning that we have digital mission engineering solutions that enable from the start of using ANSYS to be focused on the mission and meeting the requirements of that mission for whatever it is you're designing. And finally, we have the ability to connect the digital thread. And that's so important today, to have the connection of the authoritative sources of truth across the life cycle, from concept development through design, through manufacturing, through fielding and operations and sustainment, so that when you do make changes that are inevitably going to occur down the road, you're able to do them quickly and inexpensively because you're able to connect back to that original authoritative source of truth of that design and of those models.
And even retain the structural integrity of the original sort of model without completely overhauling everything.
You don't have to try to find it in someone's desktop or files. You have the exact architectural connection to where it is.
Is there anything that you and ANSYS want to impart to our Eurosatory viewers, particularly those who are just now becoming acquainted with ANSYS?
I would say that the future and being able to remain competitive future is to be open, to be mission-centric, and to have a connected digital thread. And if you take that approach, you're going to be successful, you're going to be able to accelerate to market and solve problems. And we hope that you would choose ANSYS to be a part of your solution to achieving your goals and objectives.
Steve BLEYMAIER, thank you so much for joining us. It has been an absolute pleasure talking with you.
Thank you.
And good luck with the rest of the week here at Eurosatory.
My pleasure.
That's our guest, Steve BLEYMAIER of ANSYS, who is here at the 28th edition of Eurosatory. This is Eurosatory News. We will be back after these messages, so please stay tuned.